Hello and welcome to Getting Started with the AWS Identity and Access Management webinar. My name is Jonathan Deroche. I will be your presenter for today. Here we have with us Paul Stamp, who is a Senior Security Marketing Specialist from AWS. Paul will be our Q&A moderator for today. Just a little bit background on myself as we get going. I am a Security Solutions Architect with Amazon Web Services. My role is about seeing the AWS platform through the customer's eyes and empower them to better understand the platform and how they can tie into it for their business and security purposes. Um, to that end, I'm thrilled for the opportunity to be here with you today, and let's get going. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A panel. Please submit any question that you have at any time during this webinar. Paul will answer as many items as he can in the Q&A panel while I am presenting. Towards the end of the webinar, there will be a live Q&A session where I will take the opportunity to address some questions as well. Lastly, this webinar is being recorded. We will share the recording and the presentation slides via email a few days after the webinar. So with that, let's get going. So today's agenda, we're going to start by understanding just a little bit about AWS in terms of the security framework and how we communicate that to you and set the expectations there. We will review some of the core mechanics of identity and access management and review how can you use those for the purpose of controlling your account authorization and authentication. We will be also talking about some federation options as they relate to identity and access management service, integration options with other of our services, and we will also be talking about best practices on how to implement and scale some of those configuration options in real life scenarios. Lastly, as we've talked about, we're also going to have a live Q&A section. Let's talk about the shared responsibility model. At its core, if you were to visualize the solution stack, ranging from the bare metal of the concrete of the data center all the way up to the hypervisors or the application interfaces, the API interfaces, those components of the solution stack are owned and operated by Amazon Web Services. And as a result, we're responsible for the security thereof in terms of how we build and how we operate these components of the services and your solution. And then there is a line in the sand where AWS ends and you as a customer begin. This is where you as a customer get to exercise your judgment as to which services to consume, how to configure those, and how to align those against your business and security needs. Hence, the shared responsibility model. Some things we do for you, other things as a customer you need to do for yourself in terms of aligning those to your business and security needs. Today, as we're going to be talking about identity and access management, this is one of the interfaces that we have to allow you, the customer, to control what would you like to see and not see happening as it relates to your solution. And we're going to talk about that extensively. In terms of the shared responsibility model and how it relates to you, what that means is that being a global platform that caters to many customers, AWS is managing and has implemented over 1,800 security controls, so you don't have to. We give you the option through identity and access management and other services to define which controls would you like to see applied to your workload and how would you like to govern the consumption thereof. As always, in the shared responsibility model, you, the customer, maintain full ownership and control over your data. We're going to be talking more about those configuration options. So jumping into our subject matter for today, which is the AWS Identity and Access Management Service. The purpose of this service is to enable you, the customer, to control who can do what to your AWS account and resources. Think of that as a rule set system in which you specify the rules that would dictate and govern which operation is going to be allowed or denied as it relates to your preferences, your parameters, and your resources in question. As a side note, IAM also correlates into the AWS CloudTrail service, which is our audit service that captures said API calls as they occur once they've been vetted and approved by your IAM policy, and makes those available for you for consumption for the sake of having visibility into what has happened, even though you've already approved it. In terms of service interfaces, much like many of our other services, you can consume identity and access management or configure thereof via our management console or a command line utility such as Windows PowerShell or a cross-platform CLI. You could also tie into and integrate it using the software SDKs that we publish for different languages, as well as consume and interact with IAM indirectly via other AWS services. And in this example, I'm going to be picking on our own AWS CloudFormation. Quick note to help customers understand how does IAM relate to them, right? We can group these four options into two categories. The two on the left hand are really oriented towards human consumption. A human logging into the management console or an operator running a script from his developer machine, for example. Those are operations which typically happen within the context of infrastructure operations. For example, your admin deciding to create new VMs or change the security groups thereof, or ask for more resources, or change the network configuration. Many of those operations are infrastructure or configuration oriented as it relates to AWS being your platform. On the right-hand side, these two interfaces, as example, are more programmer oriented, as in they're meant to be consumed as a part of the code of your application. We're going to be giving more examples, but imagine that you have an application that, as a part of the core mechanics of the application, you may be exchanging data and otherwise interacting with various AWS services. So two distinct workloads or two distinct mode of operations, and this is how IAM could be used for different purposes. And for the sake of clarity, because this is a question that we get often, in a given scenario where you as a customer are running your own application on an EC2 instance, for example, and the software in question does not have those SDK integration or service integrations. In this case, the normal mechanics of the application do not involve IAM. In this case, it's you, the customer, talking to yourself, as in your client talking to your server. In this scenario, IAM is relevant only from an operator or administrator, I want to change my environment perspective. And again, conversely, and we're going to talk about that more, if your software does directly integrate with identity and access management, at which point that becomes an integral part of the software conversation. And we're going to be giving more examples as to that. So at its most basic usage, identity and access management revolves around users and groups. You create different IAM user accounts as it relate to individuals or operators within your environment, and those are applied different policies. And you can also take those different users and group them into different user groups and apply different policies against the groups which by extension will also tie into different users. In terms of once you've identified and created those user accounts, their interaction with AWS is going to be a function of authentication. So for example, one method of authentication is via a username and password pair. You grant your user a user password, that's what he's going to be presenting to the AWS Management Console when he logs in and to do operation functions. Alternatively, for API access, this is where we have API access keys, which then get embedded in the SDK or the CLI, and those are used for programmatic operations as opposed to browser-driven operations. And regardless of the two, we also support as an option multi-factor tokens, either hardware tokens, as in devices that you can buy and put to use, or software tokens, as in a secret that you load on a virtual device such as a smartphone. And those grant you the ability of having two-factor authentication for added security. And of course, we recommend that you do so for added security benefits. I want to call out that we have recently announced a new feature where we provide you with a report as to when have the credentials last been used. You can see a screenshot from the console. This is very relevant for you, the customer, to know when have your credentials been used or not used, and are they actually put into regular use. If you ever find yourself in a point where you're not sure when your credentials are being used, that may be an indication that you don't have a tight handle over the usage of your environment. So please use this report to gain a better understanding of whether you have stale keys that may have not been used recently. In terms of the mechanics of the IAM policies themselves, which again, we've described could be applied against users or groups thereof, the anatomy of a policy revolves around a number of statements, with each statement having a number of sections, which you can see on the right-hand side, where we talk about the effect, the principle, the action, the resource, and the condition. Diving deeper into how those policies are crafted, here is a screenshot or a screen capture from our management console in which I've crafted a policy that entitles the recipient thereof read-only access to billing reports. So you can see from the top, the effect is to allow the service in question is AWS billing. The actions, which are behind the combo box, are the 4 view operations. Not applicable here, but for the sake of completeness, the star represents the resource in question. If you were crafting a different policy that may have related to one resource or another, this is your way of scoping it down. Not applicable for the billing example, but relevant nonetheless. And on the bottom, we see the conditions, which in our case, I just chose to put a condition based on the source IP address of 1.1.1.1, which is not overly realistic, but serves to showcase the demo of the statements and the conditions. From here, what the console does is it compiles those specifications that we've just manually provided into a JSON structure following the IAM policy convention. And if you're familiar with JSON, this is where you can see how those different statements have made their way into the structure. And this policy could be applied against users or groups. And by virtue of that, said users or groups would be allowed to do these operations, which again, in this case, is view billing information based on their source IP address or conditioned on their source IP address. Another option of generating IAM policies is in code. Depending on the complexity and depending on the use case of what is it that you're trying to do, it may be perfectly acceptable to craft IAM policies in hand and apply them manually. Alternatively, if you as a customer have an algorithm or an automated system that you would like to produce policies on your behalf, here is an example of how you could do so using the .NET SDK. If you're familiar with .NET, you can see that many of the keywords that we've hit on earlier when we were talking about the policy anatomy, talking about statements being a collection, resources, actions, and conditions, all those are present here in an object-oriented, programmatic-driven way. For more information as to that methodology, you can see the link below, and we will again be sharing those slides after the fact. Another thing worth mentioning is that as of March, we have implemented additional policy validation requirements. Those were put in place in order to protect customers from syntax errors leading to policies with unintended results. So the new syntax is available in the user guide, and you can see that link there. And it applies for every new policy which has been created following March, or perhaps policy updates. So if you have policies that were around prior to March and you want to update them now, please be aware of that validation requirement. For more sophisticated use cases, where we may have a number of users and a number of groups, and we would like to consistently apply the same policy to more than one entity, this is where managed policies come into play, which is a relatively new release. The rationale behind managed policies is to have the IAM policy be a first-class citizen, as in an object within the system that you can create, delete, list, and link into user objects either programmatically or via the console. You go to this one policy, you set whichever preferences you want using the syntax and the options we've just covered, and at that point, you can apply those to any and every users at your own discretion using the mechanics of linking and unlinking policy from the users. For your additional benefit, Amazon Web Services maintains a set of managed policies, as they're called, covering frequently used roles such as read-only, read-write, power user, auditor user, etc. Those are being updated over time as new API calls and new services are launched. So that is a way of future-proofing your policies if that's what you're looking for. And alternatively, as we've talked about, that could also be a mechanism for you, the customer, to better control and better manage your own policies as you craft them in any way that you see fit. I've mentioned CloudTrail earlier. I want to make sure that we're conveying the relevancy thereof. So when we talk about the security of the AWS platform and your options and capabilities in consuming those, there are three pillars to that conversation. One of them is the auditability of that environment. That goes into our third-party certifications and their availability to you. For more information on that, we can see our website, the compliance section of our website. The second pillar of that conversation is control. We want you, the customer, to be able to control and govern what happens in your account to your resources with your data. This is where IAM comes into play, and we're going to be talking more about that. The third pillar there has to do with visibility. Not only do we want you to be able to control, we want to communicate to you the results of those decisions that you have made for yourself. And this is where CloudTrail comes into play. CloudTrail, as stated, captures the result of the API operations, be it from the console or the SDKs or the CLIs or whichever interface you choose to use on a number of services, not just IAM, Those will get captured by CloudTrail, aggregated, deposited into your account, and at that point made available to you to review and do analysis, either for the purpose of improving the security of your environment, complying with certain compliance requirements, or perhaps reactively in terms of troubleshooting operational issues, of asking the question and getting the answer of what happened, where, and when. As a side note, as we've talked about IAM and authentication in the sense of differentiating between different user accounts and what could each one do, that propagates into the CloudTrail logs in the sense that the user identity as you've defined it will get captured in the log and reflected back into you in the aggregate thereof. Transitioning into more advanced usage and more advanced features of identity and access management, I would like to introduce a service called the AWS Security Token Service. At its core, what STS does for you is create a set of credentials which are not permanent as the regular IAM credentials, but rather STS credentials are short-lived, ranging from 15 minutes to 36 hours. By virtue of having short-lived credentials, that buys you some security functionality and comfort in terms of the implications of perhaps misplacing those credentials. Or if you have a temporary usage that you envision, you have a user that comes and goes, or a user session, this is your vehicle of providing that user with a time delimited, place delimited way of accessing the APIs, which you know will necessarily be revoked when the clock passes. STS tokens can be provisioned for existing IAM users. So if I am an IAM user, I have my policies as they apply to me or my groups, which govern what could I do. An STS token will provide me the same set of credentials and privileges simply on a time delimited space. Conversely, STS tokens can also be used for ad hoc users, as they enable you, being the account owner, to grant access not to named and pre-existing IAM users, but rather into new identities that you've decided to create out of thin air. And we're going to talk about that in a second. So leading by example, many customers want to benefit from having single sign-on to the AWS Management Console. The way in this works is on the left-hand side, the user logs into his machine, or picking Windows as an example, navigates to an internal portal, which is owned and operated by the customer himself. That portal authenticates that internal user in any way that you see fit. And again, if you as a customer are using the Microsoft stack, then you might want to take advantage of those native capabilities there. Once your own internal portal has validated to your own user, he can hand him off to AWS with that token that entitles him to log in. And at that point, IAM and AWS is going to honor that token and grant that user whichever privileges and services you'd like us to grant it. And again, in the context of console sign-on, all that could be very seamlessly rendered into the user using a series of HTTP redirects and all the logic happening behind the scenes. Peeling away the abstraction a little bit and talking more about the implementation thereof, one option or one mode of operation is via using SAML. SAML being a standard protocol for identity federation. And the idea there is that your user, using his browser, is going to talk to your broker, exchange that information. That broker is going to validate him against your corporate directory store, which is number 2. Number 3 is your identity provider is going to grant that user a token, which then the user will present to AWS being number 4 and get whichever services you want him to get. In this example, we're talking about SAML. The one thing I'd like to stress is that there is an exchange taking place. Think about the difference between number 4 and number 5. In number 4, the user has a SAML token that was granted to him by his organization. He brings that to AWS, identifies himself, and in return, he gets an STS token that is an AWS construct. So essentially, I have context switched from an organization-specific set of credentials into an IAM set of credentials that entitle me to AWS. That is the core mechanic of federation as it relates to AWS, and STS tokens are the means of getting there. And that brings us to talk about IAM roles. An IAM role is a set of permissions, much like the same permissions we can apply to IAM users and IAM groups. The distinction is that the roles are not specific to any one user and groups. It's essentially an authorization policy that's not applied against any one identity. Roles are assumed by trusted entities such as IAM users, AWS accounts, AWS services, such as EC2, and the roles themselves have two components in them. They have the trust policy, which is a new concept, which dictates who exactly are those quote-unquote trusted entity that are allowed to assume that role. And the second part is the authorization policy, which is very much in the lines of user and user groups policies, which govern what can the user do once he has assumed that role. A real-life integration point, which I would like to call out, is our AWS Directory Service. The gist of it is that it is a managed service that lets you connect to your existing on-premises Microsoft Active Directory. Or conversely, if you would like to establish a standalone directory in the cloud, directory services might be your way there in a hands-off fashion, much like what our relational database service does to relational databases. You can use the directory services in order to federate your directory users and groups into the management console using the native capability and the value add of that service in particular. We're not going to go too deep into that because it's outside of the scope of our conversation, but I want you to know that such integration point does exist and is at your disposal if you need it. More so about the mechanics of IAM and STS and roles and how everything fits together. Thus far, we've talked about the use cases of federation from AWS to the on-premises or the other way. Now I'm bringing a different example, which is federation across AWS accounts. So in this case, on the left-hand side, we have what we can label a production account with an S3 bucket that may have relevant data. And on the right-hand side, we have a development account with IAM users and IAM groups. So in this example, we have a role on the production account that has a trust policy that entitles the developers group in the other account to assume that role. At this point, those users which are a member of that group can make an STS API call, assume that role because we've entitled them to do so, in return get a set of STS credentials, which they can then use to make AWS API calls within the context of the production account. And in this case, we're talking about doing so for the purpose of entitling them to access an S3 bucket there. One thing I would like to stress and clarify is that when we talk about federation, the concept of federation is that when you entitle someone to do something for you, you don't necessarily have a line of sight into the exact users that entails. So for example, think about the production account. You trust the developers group in the development account, yet you don't know who is a member of that group. When we say that we trust that group, in practice, what that means is that we're trusting the owner thereof, being the development account, to make intelligent choices on our behalf as to who should be a member of that group. It's a transient trust relationship. A trusts B, B trusts C, therefore A trusts C, even though he only trusts B as a man in the middle. And that is what we have here. So again, when we talk about federation, federation is not about identifying who the user is. Federation is about entitling the broker of the relationship to connect the two ends together. Another form of federation that we support is what we call web identity federation. At its core, web identity is about enabling customers to tap into identity stores which are offered on the internet as a service. Differently than what we've talked about in the context of perhaps Active Directory or the directory services, in this case, we're talking about some specific services which are offered by provider. As of now, we are talking about login by Amazon, the Google authentication, or the Facebook authentication. So in other words, I don't own Facebook. I simply want to enable every Facebook user to come in and consume my app. Suppose I'm developing a Facebook game. Again, stressing on the understanding of what federation is. As the application owner, I don't know who are the Facebook users. All I know is that when one shows up, I can validate that he is a Facebook user, know who he is as opposed to any other user, and then grant him whichever service I want to grant him. This is the transient relationship of federation, and that's a key takeaway I would like you to have. Back to the example, the mechanics of the web identity federation are first, my mobile app, in this case, will authenticate that user against that web identity provider. Let's take login by Amazon as an example. Then it would get an authorization token from that provider, again being in login by Amazon. Then that application will take that token, which for the purpose of the conversation came from a third party. It's not the customer, neither is it AWS, it's Amazon.com or perhaps Google or Facebook. Take that token, present it to the STS service, and ask to assume a role. And again, going back to the previous definition of what a role is, this is where we evaluate the trust policy of the role. Are Facebook users really allowed to assume this role? Yes or no? And this next step is to be, if the answer is yes, then that role will define what is that user allowed to do. Back to our example, the STS service has received that token as a part of the request to assume that role, is going to validate that token against that provider to validate that the user is indeed legitimate. And assuming that it passed that validation, it's going to check the policy against the IAM and the definitions in the role. And if all clears, is going to communicate back to the client-side application a set of STS security credentials, which at that point could be used as a part of the SDK to make normal, direct AWS API calls to the different services. In this example, I've listed our Amazon DynamoDB, Amazon Simple Storage Service, and Amazon Simple Queue Service. And at that point, that client device is making direct API calls. In terms of facilitating this entire workflow of a user with an external identity store that's operated by an internet provider, and then facilitating his access as well as providing value-add services such as data synchronization, push notifications, and such. This is where the AWS Cognito service comes into play. It's a part of the mobile platform services. And if you have such a use case, I'd encourage you to take a look into it. Why you should care and why should you enable such a thing to happen in the first place, as opposed to having a plain old client-server application where the server component does all the AWS API calls on your behalf? Relates to the efficiencies that could be made if you were to allow the user to talk to AWS directly. For one, it may reduce the load on your servers because users are now accessing DynamoDB and other data services directly, up to the point where you may have an application that's fully supported with no servers at all. One method of doing so is not necessarily a mobile application, but perhaps JavaScript call that executes within the browser. And to illustrate that point and give more flavor to it, I would like to call out a reInvent session called Building a Website That Costs Penny to Operate. And as the namesake suggests, it involves no servers, simply services. And here is a link there if you'd like to take a look at what could be done without servers simply by orchestrating IAM permissions, external identities, and direct access to the data services. We've talked about roles. We've talked about them being used for external identities. I gave the example of corporate users of the corporate Active Directory, or users coming from the Directory Services directory. A different flavor might be identities that live within AWS services, other AWS services. So for example, Amazon EC2, the Elastic Compute Cloud, provisions VMs, which we call instances, on your behalf. Each instance has its own identity, and you may want to entitle it to make API calls on your behalf. This is where you might trust the EC2 service to entitle individual machines, which are obviously yours, through the mechanism of service roles. This is also the foundational trust relationship that you're establishing with the directory service. You're entitling the service to further entitle the users which are contained within it. And lastly, another example is AWS Lambda, which is essentially code execution within the cloud. You create what we call Lambda functions, and you can entitle the functions to perform API operations and interact with your resources on your behalf. So in this case, the relationship is you are entitling the Lambda service to pass on those entitlements to the functions that it created and ran on your behalf. A couple of best practices how to use IAM features to the maximum. First and foremost, avoid hard coding the credentials. We've talked about the usage of temporary credentials. On the right-hand side, there's also a quick conceptual walkthrough of how to rotate more permanent credentials, which we support. I encourage you to take a look at those and other best practices, which I'm going to call out, and use those for good use for the purpose of securing your usage and consumption of AWS resources. Just tying it together, trying to convey the message of how the different objects relate to each other. So we have the AWS account. Within that account, you can create your own identities, be them the IAM users in the groups, or you can create entitlements, which are roles, which again are a policy that's not applied into any one named user. Those roles could refer to other AWS services on the left-hand side, such as those that I've listed there, or those roles could entitle other accounts, other roles, external providers, and obviously this is also a recursive conversation, but that's out of scope of today's webinar. In summary, IAM is about controlling who can do what to your account and resources. For many customers, IAM could be a perfectly self-contained environment. They're a small shop. They're perfectly comfortable in creating users and groups that will exist in IAM, and that's the extent of their operations. For other customers, be it as a function of size or perhaps complexity, IAM needs to be tied into external systems, and this is where federation comes into play. Federation is also the basis of you entitling the different AWS services to act and operate on your behalf as it relates to API calls. We gave the example of EC2 instances being trusted by you by virtue of you entitling the EC2 service. And there's other services that could be used to configure and augment IAM, such as CloudFormation for managing and creating all the resources such as users, groups, roles, policies, etc. Cognito for seamless value add integration with external identity providers such as Amazon, Google, Facebook. CloudTrail for the capturing, analysis, and overview of what happened once it went past the IAM filters that you've defined, and more. For additional resources, please pay a visit to the IAM product page with the address listed there. We also offer self-paced labs. We have one for IAM in particular. It's free. I welcome you to take advantage of it if you want to kind of sink your teeth into it and get some hands-on experience. I have the link right there. For more information on IAM and AWS security in general, please pay a visit to the AWS security blog. And lastly, we've had a security track in our annual conference called reInvent. Here is a link to the Facebook playlist that calls out all the sessions that were under that security track. You will find there are sessions that go deeper into IAM, as well as other security-related services, as well as what do customers do with those services, real-life examples, and stories, and more. That also goes to say that we're going to have another conference this year, and I would welcome you to pay us a visit and learn more firsthand. More on training. We offer training using the self-paced labs, which I've called out one in particular, as well as instructor-led training. We have a section on the website that talks to that, as well as certification. We would like to welcome you to become AWS certified and gain not just the knowledge, but also the recognition of having such a knowledge. And here's a link to that section as well. In terms of disciplines, we currently offer 3 tracks for certification, be it the solution architect, the developer, and the SysOps administrator tracks with different levels of certification within each track. I welcome you to take one or all to further and demonstrate your understanding of the AWS platform.